Yep, you got to test it this Friday. Quiz on Monday. We're supposed to have a quiz today. Yes, that's the thing. Did I already collect this data yet?
Right?
Alright. So, for the most part, a lot of us said that a person who is 172.72 centimeters tall is going to collect 20 candies. I got 23, I got 24, and 25 up there. So, how did we come up with 20?
We went on the dot.
So, when we calculate the actual value, are we supposed to substitute this number in?
Yes.
Can you? When you substitute that 172 in, what are you trying to find?
The actual value.
Nope.
The residual.
Did I really miss that? I
Yo.
thought that was going in.
No. You thought
Sorry, I'm
wrong.
distracting. Hey, what? The actual value is not on that line. I'll go ahead and tell you that right now.
No, you gotta push your thing. I moved the mouse over the dot until this. I got the. It's to the top.
Look.
I say 7
What is this trend line right here? This regression line. That's what?
The predicted.
That's predicted. Because notice, here's actual data values, the points. This is a prediction. Here is the actual value. You just had to hover over it, and it told you how many candies did that person grab?
20.
20. You can even see it very clearly right here. It's on the 20. Are we clear why it is 20 and not 23 or 24 or 25? I asked what is the actual data point, right? Or what is the actual value? The actual value is that data point right there. That's it. And you can hover over that data point to figure it out until you find it. 172.72 centimeters is my height, the x value. The y value is 20. Does that make sense? Any questions about that? Okay. This is important, the next part. This is the harder part for a lot of students. What is the predicted value of a person 172.72 centimeters tall?
25.
So I see 20 up here. What is someone looking at if they said 20?
The actual.
That's the actual value. See, this is what I'm talking about right here. How many people do I have in class right now?
1, 2. Oh, you have 14. I think.
14. Got, what, 8 responses? This is what I'm talking about, and this is what frustrates me. We don't even take the time to try to do the questions even though it was over 10 minutes, or it's 10 minutes that y'all had to work on this. This is why we don't understand, and it showed on our quiz.
I said 25.
So you said 25, I see 24 for a couple people, but these are kind of like all over the place. How are we supposed to figure it out?
Look at the, what you call it again, the trend line?
The trend line, what's the other name for it?
The predicted value? No.
It is the predicted value, but it's called what? Regression line, right? That trend line is also a regression line that matters for what we talked about yesterday. So we can look here, same thing, right? We come up and we look at that trend line, but how accurate is this?
Not accurate.
It's not super accurate. To me, that looks about 24. How can we get a more accurate answer? It doesn't look like anyone did this. This is what you need to pay attention to. Thank you. That 172.72 centimeters, is that my x or my y? That's my x, right? So what can I substitute that in for?
Oh, we're going up by 6. I mean 2.
Mm-hmm.
Oh, yeah.
That x is 172.72 minus 38.2692691. By the way, I'll do it in a second. I need everyone to pick up a calculator. I need you all to type that in to figure out what the predicted value is. What's the answer?
24.1826.
24.1826. So what everyone else got?
I ain't even finished typing it in.
Okay, type it in.
That's what I did for the first one.
Okay.
Like I accidentally did.
Okay. But notice, do you understand why the first one was just
Yeah.
the data point?
Math is no bad.
Yeah, because it's in the actual.
The actual, we want the actual data point. The trend line is the predicted. So do not forget, the regression line is what is predicted. Now, I want to point this out. Here is the equation, right? There's one thing I'm missing from this equation since it's supposed to be a regression
The heck?
equation, the
Oh.
hat. Remember on this y, there's supposed to be a hat. What does that hat represent for the regression?
What is it, the candy?
Well, it is something about the candies. Is it how many candies were actually calculated, or how many candies were actually grabbed?
No.
No, it's a trend line, but what is a trend line going to do?
Predict.
There we go. That hat tells me that it's a trend line, a regression line, but it's also telling me that it's a prediction based on how, what is the x?
The candy?
It's height.
That's our height. We've got to remember that there is always a context to this. When I look at y, that's candies, and you can even write it like this, candies hat, right? That is the predicted number of candies. Is 0.361577 times the height minus 38.2691. You good with that?
I got so much work.
Okay? So we've got a predicted, we've got an actual. So what are we going to do in order to calculate the residual?
I must subtract the actual height from the predicted height.
So I'm going to subtract the actual from the predicted, so predicted minus
No, I mean
actual.
predicted from the actual.
So I need everyone engaged in this. Raise your hand if you think it is the first option right now. Is the residual the predicted minus the actual?
No.
So no here. Raise your hand if you think it is actual minus predicted. Not sure? So why don't y'all look at what everyone else is thinking. What are they saying? Raise your hand again if you thought it was 2.
Oh.
Looks like that's the majority of us. So maybe the actual minus predicted. Where can we go to determine if that is correct or not?
No.
Your notes from squared up. You need to know that the residual comes up and squared up. So I need actual minus predicted. What was the actual value?
24. I mean 20.
20. So the residual would be 20 minus what?
24.
24.
Is it 24?
What is it for the root?
24.185.
Or 26, whichever one you got in your calculator. So there we go. So what is my residual?
4.
Is it 4?
Maybe 4.
Is it negative 4?
No, it's 4.
Is it 4?
Oh my God.
Which one is it?
4.
Negative 4 point.
Negative 4. Okay, so she actually put it in her calculator and it was negative 4.
Oh, I knew it was 4. It was making me unsure.
Then you didn't know.
What? Yeah.
No, So there's our residual. Now this is important. What does that residual mean?
That
Okay.
how far it is from the line.
How far it is from the, what is that line representing?
Prediction.
The prediction, the trend line, right?
Oh.
So what does the fact mean that it's negative 4.1826? Why is it negative?
Because going down is below the line.
It's below the line, right? Because can you have negative number of candies?
No.
No. This is telling me that this individual, this person, grabbed 4.1826 candies, what?
Hat.
Hat?
I don't know, it sounds right.
I mean, did they grab 4.1826 candies?
No.
No. You said it's below the line, right?
Yeah.
So it was predicted that they would grab 24.1826. They grabbed 20. So they grabbed 4.
Oh, yes.
Less. That's what we need to recognize. I'm going to go ahead and tell you. On your test, you're going to have to interpret a residual. I am telling you that here and now. This person grabbed 4.1826 candies less
Then what
than,
the actual value,
no, because that was the actual.
how many didn't predict?
It was less than the predicted.
Potato.
Ooh, very different. Now, when I was in high school and when I was in college, when a teacher literally told me, this thing is going to be on a test, I usually wrote that down. Just good sense.
I know it.
And I would even star it and say, hey, this is going to be on the test, interpret a residual. We got to learn how to be good students. This is something that's hurting you. You got to know what to make sure you have in your notes. This is a very straightforward thing. This is going to be on our test. I need to know that. You got to be able to interpret a residual.
We finna be working on it all day, aren't we?
Huh?
We finna be working like interpreting all that, whatever, for the day.
We're going to interpret residuals. We're going to interpret slopes, y-intercepts, all that kind of stuff. Okay? I'm scared to look at the last question, so I'm not going to look at our responses there. I know I had at least one person correctly tell me it was slow, because I saw them typing that out. Before we get to that though, okay, I want to send this back out to everybody. Okay? So, open up that file that I just sent you. This is from Squared Up yesterday. I want to look at a relationship between the years that have gone by and the average expected life, or the average life expectancy for people. How am I going to do that?
Don't you click the add variable?
Just got to click on the add variable.
And don't you do year?
Okay, so the year is my predictive variable, my x, or independent variable.
And then you click add variable on the other side, and ain't it person?
The person was what it was for all people. Okay?
Oh, you trying to, now we gotta do the line?
Not yet. Okay? We all good with how to create that graph right there. Yeah, we're going over stuff you missed. It helps keep to do the stuff on the calculator to learn. Okay? So from here, we did do a trend. We did the least squares regression line. How would I do that?
Don't we click menu?
Are you showing him how to graph the data points or do the least squares regression?
How to do what we get right now?
Oh, okay. You have the data graph though, Brandon? Okay. So where am I going to go to once I have the data there?
Click menu.
Menu.
We go to analyze.
Go down to analyze.
And we click add movable line, don't we?
You can do movable line,
Regression.
but we want to do the regression because I don't just want a movable line. I want the best trend line and show that linear. Mx plus b is fine, yeah. Just gotta click there and add it. Go to menu. Alright, so I am going to go to menu, analyze, regression, and show that linear regression. What is the point of this least squares regression line? So I'm going ahead and remind you, this is called a least squares regression line. What is the point of this?
To show you the
So I want you to remember, is there more than one regression line possible?
Yes.
Very much so. Remember how we took that movable line yesterday? We moved it around to see lots of options?
yeah.
Yeah. So do we just want any regression line?
No, we always trying to get the smallest.
Smallest number of what? We want the best trend line. How do we get that best trend line?
You talking about how we get it to pop up?
Well, why are we going to know? We haven't shown it yet, but how do we know that this is the best trend line? Smallest number of squares. Remember how it's the least squares regression line? So that means the sum of our squares is smallest, right? When you went to, if you went to residual and you showed your residual squares, did we ever get anything that had a sum of squares less than this? Did we ever get a sum of squares less than this number?
No.
No, we did not, did we?
Mm-mm.
Okay, that's what we want to recognize, is that that least squares regression line is going to minimize that sum of squares. That's how we know it is the best regression line or best trend line. That's what's happening. Do we have to go through the work of moving the line every single time?
No.
No. We just need to understand that when I hit show regression, it's giving me the least squares regression. Okay? From there, we got this equation.
Yeah.
We should already have it written down from yesterday. How did we interpret that slope? So like we have this, well, first off, what is my slope? What does m equal?
0.26619.
Now, how do we calculate slope, Maven? Rise, not over. Okay, we want to remember it's rise divided by run. And that's important because technically what's being divided right here?
1.
Now I have a rise and I have a run. We all good with that?
We skim.
Ma'am.
Spare on the air just for a little bit.
Huh?
Spare on the air just for a little bit.
Like turn up the temperature? Turn up heat. Just a little bit. Okay. So, here's what we want to recognize. We interpreted this. I think we wrote it down under number 15 or 16 yesterday under the squared up task. So pull out your squared up task, look at this.
15. Oh, you said 15 or 16.
It was 16, yeah. Okay? So when I look at this, these numbers have meaning. When we say rise, which variable are we talking about?
Wow.
That's a y. We all good with that?
Yeah.
And in this problem, in this context, what was the y?
The life thing. Life is
Okay? So this was my predicted life expectancy. So what is the one, the run?
every year.
That's the year, right?
Yeah.
Okay? The year since 0 AD. Notice how we're looking at 1900 here. And 1910 and 1920. So the run, that is the year. And so we interpreted this slope. What I mean is, in context, what does this mean? Well, for every year that goes by, and I will tell you this right now, on the test, you will have to interpret both slope and y-intercept. There are multiple questions with that.
For every year that goes by, we predict the life expectancy, whatever you say, to go up by 0.266.
So for every year that goes by, we predict the average life expectancy to increase or decrease?
Increase.
Why is it increasing?
Because it's above the line. Because it's positive.
Because it's positive. It's going up. Right? So we expect the life expectancy to increase by,
0.266.
and it's fine to go to 3 decimal places. So, interpreting that slope, for every year that goes by, we predict the average life expectancy to increase by 0.266 years. Are we saying that the life expectancy will always increase by that much? No, we predict it. The regression line. We are all good on that. Okay, you will have to practice that today and tomorrow to be ready for the test.
What the day is?
Today is Wednesday.
Oh God.
Next part though, we also talked about the y-intercept. This is important. The y-intercept is the y value. What do we automatically know about the x value? It's what? Oh, come on, we should know about the y-intercept. talked about this yesterday as well.
It's our predicted, it's our actual.
I say who?
Oh, 0?
Thank you.
Oh, 0.
Oh.
Right? It's 0 comma something. Anywhere on the y-axis, it's a 0 comma something. So, what are we saying here? 0 what?
Divided by,
No.
multiply.
That's a point. 0 what? What is my x?
0 years.
So at 0 AD is literally what we're saying. At 0 AD, again, this is a prediction. We predict what? The life expectancy
Will go up,
Was
will increase, or,
was, right? There's just year 0. The life expectancy was what?
negative 4.5.
Not even 4. 454.
36. And 4.
That's how we would interpret that y-intercept. Thank you. Right? At 0 AD. Once again, is this going to show up on the test?
Mm-hmm.
Yes. You gotta know how to do this. Anyone have a problem with that? Yes. No one has a problem with the fact that life expectancy was negative 454.364 years.
I mean, it doesn't make sense.
Yeah, does that make sense?
No.
Heck no. This is, and you need to make a note about this as well, this is the danger of extrapolation.
What? The words.
Weirdly enough, we've mentioned this word before, and two, I'm about to define it. Extrapolation. This is the danger of extrapolation. What we mean by extrapolation is predicting values outside the data set. Did we have any data points anywhere close to the year 0?
No.
No, what's the lowest year we had?
19, and like.
I think the lowest
1890.
data point was actually
1890 something.
that. No, the lowest data point was 1900. So it's between 1890 and 1910. So the lowest data point we had,
That back already?
apparently. Come on in, come on in. Okay, thank you. So the lowest data point was the year 1900, so would it make sense to use that to predict year 0? No, right? That's a huge, huge, huge difference, okay? That is the danger of extrapolation. That's predicting values outside the data set. We mostly interpolate. What do you think we mean by interpolate then? Okay, do what with points inside the data set?
Predict.
We predict values inside
the data set.
the data set. Bree, at this point I'm just suffering for it to be warmer in here and you're still not talking. I need you engaged. Same thing with Caroline and Key. Come on. We mostly interpolate. We predict values inside the data set. We can extrapolate a little outside the data set, but not 1900 years. Does that make sense? Okay? So, again, you're going to have to interpret slope and interpret y-intercepts for the test. I'm telling you that right here and right now. So you got to be able to explain what those numbers mean. That being said, one of the questions on the bell ringer was to interpret the meaning of 0.361577 in the context of the variables. I want you to take 2 minutes. I want you and your group to come up with an interpretation for this number. 2 minutes, go. Talk with your group. Jordan, if you want to move to this group or group 4, you can do that. Okay?
Fix your calculator.
It's,
Keith, you gotta stay awake, you gotta do something, come on.
Yeah, I got a headache.
Huh?
Part of the year, and the person on the side.
Well, I just need you to focus on this bell ringer question up there. No, we went over a bunch of other stuff, and I'm coming back to a question on the bell ringer. So I need you to look up there, I need you to interpret what that 0.3615577 means in the context of the problem. Which there was, notice, that's based on this, the number of candies grabbed based on the height of a person. So keep that in mind, that we are looking at this set of data with height and candies. So interpret that value. We should probably be writing something down. Kind of. Coming back to it. Don't pull it up on the calculator. Interpret that number. Write it down somewhere. Talk about it. Try to figure out what it means. Okay, so what's the run if that's the rise? So partially, that's a big part of it. Keep going with that. This is slope that, so interpret what that means in the context of the problem. Something with candies.
How many years?
I can't have no.
Okay? Okay. So, I've already heard there's a 1 up under it. Does anyone disagree with that? That's 0.361577 divided by 1? Okay? And I heard some people say already that that's my slope. Well, the divided by 1 is my slope. So which part of this is my rise?
The top.
Okay? And so we know how to calculate slope, but in the context of this problem, what is the rise? What variable are we talking about there? Candies. So then what is this 1?
Inch, the height is your height value.
So that's the run, which is my height. Now this 1, positive or negative?
Positive.
So if someone's, so how would I start this? If what?
If,
Oh,
I don't know, for
every,
Centimeter somebody?
for every
okay. So for every
centimeter,
1 centimeter
we predict
increase in what?
height.
In height, okay? For every 1 centimeter increase in height,
We predict.
.36 more candies, bro?
we predict,
We predict 0.
That .36,
what that 0.36, what are you talking about there?
the candies.
We predict.
That they'll grab.
So we predict the candies grabbed does what?
Will rise
Will rise.
So increase,
by 0.361577.
there we go.
I did it.
No, we did it.
No,
You didn't even say that.
Okay,
I've been doing it. All the real, that's the guy.
any questions about this? Feeling good? Ish? Learning? Getting better?
Yes.
Okay, I want to go ahead and say this, because Kyron asked it earlier, am I still using the rubric to grade active collaboration? Yes.
Great question.
Yeah, every day.
I know she is a free.
Okay, so for you it starts now.
So don't start it, don't it start at 3 or 2?
It doesn't start anywhere. It's what you showed me to start and then how you end.
Oh.
Okay? So like,
I got the clear.
Kyron, super engaged, very high score on the rubric right now. Like, that's something we want to notice. I believe Emily's been involved a good bit and Anaya's been involved a good bit. Haven't heard a whole lot from everybody else. You've got to show me that you're being engaged.
Question, alright, say like you doing your group work with your group, right? But like you just not talking, but you doing your work.
You're looking at a 3.
So just not talk back to you.
God, I must have my mind.
If you're not talking, you can't
No, I'm
earn fours
saying,
and
like,
fives.
Like you.
If
at
you're
the
talking with
collab-
your
Yeah.
group, that's what matters.
That's what I'm saying, like, if you just at the collaborate with your group, but then when you get, when you talking to the class. you
In
know what I'm
order
saying?
to earn a 5, well actually to earn 4s and 5s, you have to be actively engaged in
With
the
the
whole
whole
class
thing.
discussion as
Alright.
well. You gotta be engaged on both sides of it. Alright, that's not what I want.
So if you average a three, if
Question.
you
Oh.
average a 3 the whole week, what you looking for?
75%. Because the average, the 100 is a 4.
So 100 could be a 4, and then 120, something like that, could be a 5.
So, yeah, so if you are average of 5, you're looking at 120%. It's possible. Really quickly, I do want to point this out because this was a question on yesterday's exit slip. A lot of people said, yes, this would be a good trend line. However, I want you to look at these data points.
They know, they're not evenly split.
It's somewhat evenly split. There's only 5 data points, but when you look at those data points, there's a very clear what there?
Curve.
Curve. Does the trend line get close to those points?
No.
Oh,
Yeah.
I mean, yeah, that trend line gets close to those points, but there's a very clear curve. If you remember yesterday when we talked about the regression line, the data points need to be scattered around that trend line. This isn't scattered, this is a very clear curve around it. If it was scattered, it would look something like this. You see how there's no clear pattern around there? That would be a good trend line for that data. But because there's a clear curve around it, that's not going to be linear. I think I actually used a quadratic to make those data points. Okay, so that's something to be aware of.
What's that?
Huh? Okay. So let's get to today's lesson. Thought I already had it open. Apparently I don't. So I'm sending this data back out.
Small.
I need you to open it up and I need you to follow along. Okay? So, I also need you to get the candy grab activity back out and look on the back side because we're doing the candy grab activity revisited. Huh?
Ooh.
Candy grab activity? No, it says candy grab activity.
Oh,
Please.
Huh?
you already know, the collaboration points are going down.
What time you
Well, I had first block and then I had third block.
Get your butt out.
Okay.
And I'm tired. Look, I got pens.
And then you got that,
And I got.
Can you do for that point?
If you start disengaging later within the class period, then yes.
What if I was to fall asleep?
If you fall asleep, then it depends on, if you look at the rubric, it very clearly says like, in order to be a 4, you have to be actively engaged in talking at least 70